Our topic for today is talking about our double angle identities. So what happens if I'm taking the sine, cosine, tangent of an angle that is twice the size? So it's no longer theta, but it's 2 theta. We are not going to talk about these half angle identities. So I'm just going to cross those out for right now. We're not going to talk about them at all this year because of time. So our double formulas, the easiest one is sine 2 theta. Sine 2 theta would be equal to 2 times the sine of theta times the cosine of theta. Tangent 2 theta is very similar to what you saw from your tan of A plus B. And then notice that cosine 2 theta, it has 3 options. And they're all equivalent. Any one of them would work for your questions. There are times where it's going to be helpful to use one versus another. I do want to show you something. If I'm finding sine of 2 theta, these formulas are all coming from your sum and difference formula. So they're all coming from the orange box. Here's how. If I'm talking sine of 2 theta, really what I'm talking about is sine of theta plus theta. And if I used my orange box from our last class, that's the same thing as sine theta, cos theta, plus cos theta, sine theta. Well, those are the same thing. And so really what I have is 2 sine theta cos theta. So our formulas are all just manipulations of your sum formulas that you saw in the orange box. So just like that day, we're going to see some questions that ask us simply to condense an expanded formula. There are also going to be some questions that ask us to expand and to verify. Our first example is asking us to get an exact value for the cosine squared of 22.5 minus the sine squared of 22.5. Once again, this means the same thing as cosine 22.5 squared minus sine 22.5 squared. Sometimes it's just nice to be reminded of what that notation is talking about. So I don't know anything about 22.5. So it's not asking me to give exact values from here. It's asking me to use one of my formulas to condense this into something that I do know the exact value of. So do you see a formula in our green box here for a cosine squared minus a sine squared? And it's our very first one. This must be equal to cosine 2 theta. And theta in this question is 22.5. So really I'm asking for cosine 2 times 22.5, which is cosine 45, which is radical 2 over 2. That's all it's looking for. Our next one is not as straightforward. I'm just going to paste my box of identities here. Notice how I cut off the lower identities because we're not working with them. So I want to find sine 75 times cosine 75. Now we spent a lot of time finding sine and cosine values last section of 75 degrees with a sum or difference. So yes, I could find sine 75 using sine of 30 plus 45, and cosine would be cosine of 30 plus 45, and then take my two answers and FOIL them together. Here's a simpler way. I notice that I have an identity right here that is almost what I'm looking for here. If this question had had a 2 out in front, this would have equaled sine of 2 times 75. But it's missing that 2. So what I'm going to do is, could I simply multiply both sides by a half? So wouldn't 1/2 sine of 150 be equivalent to sine 75 cosine 75? Now the benefit of that is I know sine of 150. Sine of 150 is simply the positive version of sine 30. And if you look at your chart, that's 1/2 times sine of 30 is also 1/2. So I get positive 1/4. So maybe you add in a separate identity here. 1/2 sine 2 theta is equal to sine theta cosine theta. Our next question says use a double formula to find the exact value of cosine 300. Now we know the exact value of cosine 300. We've done it before. We said cosine 300 is a fourth quadrant reference angle of 60. So cosine in the fourth quadrant is positive, so it's really cosine of 60, and cosine of 60 is positive 1/2. So I know my answer should be a half here. But it says use a double formula. So here are my double formulas. And it's cosine. So can I rewrite this? I want to take cosine 30, or 300, excuse me, and rewrite it as cosine 2 times 150. So in my questions, theta is going to be 150. So now I'm going to use one of these formulas. It doesn't matter which of those formulas you use, they should all work. If you don't want to use both a sine and a cosine, then use one or the other. Maybe we'll do the bottom one. I just chose that. But I know that cosine 2 times 150 should be equal to 1 minus 2 sine squared of 150 degrees. Well, that's the same thing as 1 minus 2 times sine 150 squared. And I know sine 150 is equal to sine 30 because 30 is its reference angle. And 150 is in the first or the second quadrant, so it's positive. Sine is positive in 150. And I know what the sine of 30 degrees is. It's 1/2. So 1 minus 2 times a fourth is equal to 1 minus 1/2, which equals 1/2. So it's an alternative way to getting that exact value. Our next two questions are verify questions. So they're similar to what we've seen in each of our units here. Now, we are not limited to just using our green box. I'm going to paste our green box right here. So we do have that there. But we could also use any of our Pythagorean identities from the pink box or any of our reciprocal identities from the pink box. So my goal is to make it look like the right-hand side, 2 tan theta. Currently, I have sine 2 theta over 1 minus cosine squared theta. So 2 theta and theta are different angles. They act differently. If one of them is 10 degrees, the other one is 20 degrees. They don't have the same trig ratio. So for example, sine 2 theta is not going to cancel with sine theta to be 2. They're going to be different. So I'm going to start with this. I want to get rid of this 2 theta if I can. And I know sine 2 theta is equal to 2 sine theta cosine theta. Now, if you think back to your pink square, 1 minus sine squared is equal to something. 1 minus sine squared, isn't that a Pythagorean identity that gives us cosine squared? That's from your pink box of identities. Well, that's good because now what I have is 2 sine theta cosine theta over cosine theta times cosine theta. So those cosines are going to cancel. And what I'm left with is 2 sine theta over cosine theta. Now the 2 is just being multiplied by that sine theta, so they're not forced together. And that's good. I have a 2 in what I'm trying to get to. Well, what is sine theta over cosine theta? That, from our pink sheet of identities, is simply tan theta. So 2 tan theta is equal to tan theta.